So far in the last lecture, we have studied about encoder and decoders. Now another switch which is commonly used in computers, that is the multiplexer. So sometimes we say multiplexer as a data selectors. It converts parallel data into serial mode. A multiplexer is a device that allows digital information from several sources to be routed onto a single line for transmission over that line to a common destination. That means we can say that if the data is coming parallelly, after using a multiplexer, it will be converted into a serial mode. So as far as its block diagram is concerned, it has several data input lines, some select lines, and select line is always less than the input line, and a single output. The relation between select line and the input is that if there are n input lines, then m select lines are there, and the relation is 2 raised to the power m equals to n, where n is the number of input lines. Or we can say if we have n select lines, then 2 raised to the power n is the input lines. So that will be much clear from the block diagram. Here is the block diagram of multiplexer. We have n number of input lines here. This is the select line and output is just a single output. So it acts as a switch, means it will connect the input to the output depending upon the value of the input select lines. So whatever is the value of the select line, such input will be connected directly to the output, and data will flow from that input to the between that input and the output. So it will act as a switch. You can see this switch, and the position of the switch is decided by the select line that we are going to discuss in the next slide. So the first one is 2:1 multiplexer. That means we have two input line and one output, and for two input line we should have only one select line, and the relation is that 2 raised to the power s is the select line equals to number of input. When input is 2, then we have single select line, and the output is like this. Whenever s is 0, s is the select line, the output will be I0, that is the first input. When s equals to 1, then the output will be connected to the second input I1. So this is your block diagram of the 2:1 mux. We have two inputs I0 and I1, a single select line S and a output Y or Z. Now what happens when S is 0? Whenever S is 0, output is connected to I0. When S is 1, output is connected to I1. And we can find out the relation like Z equals to S0 I0 or S I1. So here is the relation. Here is select line. S I1 comes from here, and S0 I0 comes from here. So S bar I0 plus S I1 equals to Y. And that relation can be drawn directly from the truth table. Similarly, we can construct a 4:1 mux. Again, here input lines will be 4. So for the 4 input lines, we should have 2 select lines and 1 output line. So here is the truth table. Two select lines S0, S1, and 4 inputs I0, I1, I2, and I3. Whenever input is 0, 0, there will be connection between I0 and Z. For input input select line 0, 1, I1, 1, 0, I2, and 1, 1, I3. So in this way, the circuit will be designed that output will be I0 whenever S0 and S1 are 0, 0. So S0 and S1 are 0, 0. We have put it two NOT gates. So it is S0 bar, S1 bar into I0. That is the first input. Then output will be I1 when S0 is 0 and S1 is 1. So here comes S0 is 1, S1 is 0. Similarly, we can construct in 8 is to 1 mux, and for 8 is to 1 mux, we require 3 select lines. So this is the way how we construct the multiplexer. Now, the multiplexers with more number of inputs can be obtained by cascading 2 or more multiplexer with less number of inputs, as we have done in the case of the decoders. And we can construct a large number of decoder with the help of the small number of decoders. Now, here we have put it an example to construct a 16 is to 1 mux using 4 is to 1 mux. So again, the number of mux are find out 16 into 4 divided by 4, 16 into 1 divided by 4 into 1, that is equals to 4. So here we require 4, 4 is to 1 mux, and the circuit is like this. We have put it 4 mux, 1, 2, 3, 4. For 4 is to 1 mux, we require 2 select lines. So we have put it 2 select lines here. Again, the output is x1, x2, x3, x4 like this. Now this output of the each mux will be input to the next mux, and we have again used a 4 is to 1 mux, whose select lines are S2 and S3, and it must be kept in mind that the higher order of select lines will be at the outer mux. So S0, S1, 2 select lines for the 4 is to 1 mux, and S2 and S3 are the next 2 select lines which are used for the next number of mux, that is at the output. And again, we can find out that for the 4 is to 1 mux, we require 4 select lines. So we have 1, 2, 3, 4 select lines. And for single 4 is to 1 mux, we require 2 select lines. So for each and every 4 is to 1 mux, we have used 2 select lines. So here you can see directly that the select lines for the first level is common to all the muxes, and the select line for the next level is different. The implementation of Boolean function using multiplexer, a question of 5 marks will be there in your sessional exam as well as in your main term exam for implementing a Boolean function using a multiplexer. So suppose you are given a Boolean function f equals to a, b, c equals to a bar, b bar, c plus a, b. So what we need to do here, we have to convert it into canonical form, and then we have to construct a truth table. So in this case, A, B, C, whatever is the input will be your select line. So here A, B, C, 3 inputs are there. That means there will be 3 select lines A, B, C, and the input according to this select line will be 8. 2 raised to power 3 equals to 8. So we require an 8 is to 1 mux for implementing a Boolean function with 3 input lines. So I have converted it into canonical form. Then I have put it the result in a truth table. So here is A bar, B bar, C, and AB is divided. When I'll expand AB, it will be AB C bar plus ABC. So ABC bar is this 6 and ABC is 7. So we have 3 ones here. And what we do when we are using a simple 8 is to 1 mux, we put the value of the output directly to the input lines. So 0 is I0, 1, then 0, 0, 0, 0, 1 and 1. So 0, 1, 2, 3, 4, 5, 6, 7. These are 8 input lines, and whatever is the value of the output, the truth table, that will be directly implemented with the help of the 8 is to 1 mux. Now we have 3 select lines A, B, C, and the select lines are connected to the A, B, C as the input equals to select line. So this is the way how Boolean function can be implemented using numbers of the same size, whichever is if the number of input lines and the select lines are equal. Now there will be a question when we have to implement such Boolean function with the help of less number of less size of the mux. Suppose we have to implement the same Boolean function with the help of a 4 is to 1 mux, then we have only two select lines for the 4:1 mux, and we have to obsolete, or we have to neglect and the one input, and the process will be shown in the next slide how it is done. Suppose we have a Boolean function f equals to xyz equals to summation of minterms 1, 2, 6, 7 using 4:1 mux. Now, if the case was, we have to implement it with the help of 8:1 mux, because there are three input lines. Then the size of the mux will be 8:1 with three select lines, and in that case, all select lines will be equals to input x, y, z, and whichever minterm is 1, that will be 1 at the output input, and other rest will be 0, what we have done in the last example. So here we have to implement it using 4:1 mux. So what we do, first we construct the truth table, x, y, z, three input lines, 8 combinations, and whichever is 1, 1, 1, 2, 6, 7. These Boolean functions are 1. These are the minterms, and the rest are 0. Then what we do, we make a pair of 2 in each input and output line, and you can see for each pair the value of x and y is same. For the first pair, xy is 0, 0. For the next pair, it is 0, 1. For next pair, it is 1, 0. And for the next pair, it is 1 and 1. And now we compare for the same input of xy the value of z and f. So you can say whenever z is 0, f is 0. Whenever z is 1, f is 1. So we can say f equals to z, like this. In this case, when z is 0, f is 1. When z is 1, f is 0. We can say f equals to z bar. Now for the next case, whatever is the value of z, either 0 or 1, f equals to 0, we can say f equals to 0. And the next, whatever is the value of z for the constant value of input x and y, f has a value f equals to 1. So we can say f equals to 1. Now these are the input lines to be connected to the 4:1 mux, z, z bar, 0 and 1. So we have a 4:1 mux, two select lines x and y, 4 inputs. The first input will be z, next z bar, next 0, next 1. So these are the input we have imported directly connected to the input line of a 4:1 mux. So whenever you have to implement a Boolean function with the help of a mux, first of all you have to find out which type of mux is required. Otherwise, the size of the mux will be, input will be select line. In this case, if we have to implement directly with the help of 8:1 mux, then these are the input lines which will be connected directly to the 0 or 1. Now as we have to implement it using 4:1 mux, we have to make a pair of 2 for the equal number of input x and y, and we have to compare the next input to the output. In the same manner, we can take one more example. Suppose we have a given Boolean function f equals f a b c d. That is, we have 4 number of inputs. Then the size of the mux that can directly be implemented used for this implementation is 16:1. But we have to implement it with the help of 8:1. That means for the 8:1, 3 select lines are required. So we use A, B, C as select line, and D will be neglected as an input. So again, I construct a truth table. I put it the values 1, 3, 4, 11, 12, 13, 14, 15. These are the minterms which are 1, and the rest I have put it 0. Again, I made a pair of 2, and for each pair we can see that value of A, B, C is equal. For the first pair it is 0, 0, 0. For the next pair it is 0, 0, 1. For the next pair it is 1, 0, 1, 0, 1, 0. Then 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So for each pair, we have equal value of A, B, C, and here we will compare the value of D and F for each of the pair. And when we compare, it comes like this: 0 to 0, 1 to 1, that is F equals to D. 0 to 0, 1 to 1, F equals to D. 0 to 1, 1 to 0, F equals to D bar. Here in this case, 0, 0, then 0, 0, 1, 1, that is F equals to D. For both cases, value is 1, F equals to 1, and F equals to 1. Now we have 8 inputs and we can implement with the help of 8:1 mux. We put it A, B, C as select line, S0, S1, S2, and we have 0 to 7, 8 inputs, and inputs are connected. The first is D, next is D, next is D bar, next is 0, 0, then D, then 1 and 1. So this is the way how we convert or how we implement the Boolean function with the help of multiplexer, which has less number of select lines as required in the Boolean function. So again, you can have a practice example. Implement this particular Boolean function with the help of 4:1 mux. So this will be a home assignment for you all, and you have to solve this and implement using 4:1 mux. Let me